Consider this. We live on a water planet. Through the millennia, the water cycle has supported all life. Shaping weather, seasons, and climate, providing habitats for most of the world's living things, and most of them, including us, are almost entirely made up of water. Now consider this. Water is a finite substance, a limited resource. Only a tiny fraction of the Earth's water is fresh. It supports everything from agriculture and sanitation to aquatic ecosystems like rivers and streams. Water falls unevenly across the planet, while much of it is locked up in glaciers, permanent snow cover, ice, and permafrost. Water is also stuck underground, very deep in the earth and hard to reach. To make matters worse, water is being threatened by pollution, overpopulation, climate change, mismanagement, and war.
That's why every gallon of harvested rain is important. It means less water is drawn from ground sources, rivers, and reservoirs, and less energy is required to treat and deliver the water. Water conservation also helps cut down on emissions from power and wastewater treatment plants. Remember that each gallon of water has been delivered by pumps from a water reservoir to its point of use. After it is used, energy is needed to transport the water to a centralized wastewater treatment facility, where it is aerated, settled, filtered, treated, and then transported to a discharge point. It has been realized by the scientific community, policymakers, and now by public that the current wasteful urban metabolism, including water management, is not sustainable, overuses resources, requires a lot of energy, and emits excessive amounts of greenhouse gases. There is a need to implement water conservation and change the current linear system of water management and the entire urban metabolism to a cyclical system that would not only save water and energy but also be attractive to developers and city planners and desired by the public. This paradigm of urbanization is based on the premise that urban waters are the lifeline of cities and the focus of the movement towards more sustainable cities. Rainwater harvesting captures and retains rainwater from roofs to be used in potable and non-potable ways. Rainwater tanks can be integrated in buildings or underground, desirably near the catchment area. And rainwater harvesting can be adopted to increase soil moisture levels for urban greenery, to increase the groundwater table through artificial recharge, to mitigate urban flooding, and to improve the quality of groundwater. In China and Brazil, rooftop rainwater harvesting is being practiced for providing drinking water, domestic water, water for livestock, water for small irrigation, and a way to replenish groundwater levels. A rainwater harvesting system consists of three basic elements: a collection area, a conveyance system, and storage facilities. The collection area in most cases is the roof of a house or a building. The effective roof area and the material used in constructing the roof influence the efficiency of collection and the water quality. A conveyance system usually consists of gutters or pipes that deliver rainwater falling on the rooftop to cisterns or other storage vessels. Both drain pipes and roof surfaces should be constructed of chemically inert materials such as wood, plastic, aluminum, or fiberglass in order to avoid adverse effects on water quality. The water ultimately is stored in a storage tank or cistern, which should also be constructed of an inert material. Reinforced concrete, fiberglass, stainless steel are all suitable materials. The technology is suitable for use in all areas as a means of augmenting the amount of water available. Some advantages include rainwater harvesting provides a source of water at the point where it is needed. It is owner-operated and managed. It provides an essential reserve in times of emergency and or breakdown of public water supply systems, particularly during natural disasters. The construction of a rooftop rainwater catchment system is simple, and the local people can easily be trained to build one, minimizing its cost. The technology is flexible. The systems can be built to meet almost any requirements. Running costs are low. Construction, operation, and maintenance are not labor-intensive. Rainwater harvesting systems require few skills and little supervision to operate. Major concerns are the prevention of contamination of the tank during construction and while it is being replenished during a rainfall. Contamination of the water supply as a result of contact with certain materials can be avoided by the use of proper materials during construction of the system. The main sources of external contamination are pollution from the air, bird and animal droppings, and insects. Bacterial contamination may be minimized by keeping roof surfaces and drains clean, but cannot be completely eliminated. How much water can be collected by a rainwater harvesting system? According to Innovative Water Solutions, a building that has a roof footprint of 20,000 square feet will harvest 677,000 gallons of water a year. Let's take a closer look at how we implement the water harvesting system. Catchment. Rainwater harvesting can be done with any roofing material if it is for non-drinking use only. For potable use of rainwater, the best roof materials are metal, clay, and cementitious, although all roof material types except asbestos have been used. Asbestos roof materials used in older homes should not be part of a system to provide drinking water. Asphalt shingles can contribute grit and leached chemicals to the system, and a pre-filter will be needed for the water before it enters the cistern. Lead materials in any form, including flashing, should not be used. Conveyance. Rain gutters convey water from the roof to the pipes to the cistern. Storage. The storage tank can be located above or below ground. The best material for cisterns include concrete, steel, ferro-cement, and fiberglass. When ordering a cistern, specify whether the cistern will be placed above or below ground and if the cistern will be used to store potable water. Filtration. Dirt, debris, and other materials from the roof surface may contaminate the rainwater. The best strategy is to filter and screen out the contaminants before they enter the cistern. Pre-filtering to keep out debris will reduce sediment buildup. A leaf screen over the gutter and at the top of the downspout is helpful for this purpose. Distribution. When water supply becomes limited, practical solutions can fill the gap. Rainwater harvesting systems can supply the water that will be used for irrigation, flushing toilets, or any other non-potable use for water. The systems are becoming more economically feasible and can be configured to the building, the location, and its use. You will discover that once we start collecting rainwater, we will begin to care more about how we use water in our daily routine. Also, when it rains, we will have a sense of contentment that our cachet of water is growing.